Alright, I guess we are on air. Hello everyone, back again to our podcast. So here I am, Adil, and I'll be the host this time. And as usual, there are Andra and Randia. How are you guys doing, man? You doing good?
Yeah,
I'm
yeah,
good.
yeah. Yeah, I'm doing good right now. Thank you for your rounds question.
Me
Yeah,
too.
see, good. That's nice to hear. So, okay, we can know already, as we have known already, the title for this podcast topic is um, Voltaic Cell Part 2. And Andra, because you are the guest this time, I want to know what are we going to discuss today. Okay,
Hello?
so testing. Can you hear me?
Well, yeah. Your first is actually staged.
Oh my
Yeah,
god, I guess
the same
my
as me.
computer is really lagging. I'm going to close some application. Alright, are we good now? Or still
Yeah,
lagging?
yeah.
Still
I mean,
lagging?
although your visual is lagging, however, I can hear you clearly. I mean, there's no problems when it comes to sound.
Alright. I guess because in this podcast it is my OBS, my live streaming. As long as I see you guys not lagging, it will be fine.
All right. Okay. Yeah, I will call you if you are unrespond.
Alright. Please let me know. Okay, so Andra, what is this about for Textile Part 2?
Yeah, Voltaic Cell 2 actually is a part of electrochemistry podcast series. It will discuss about how we can arrange the uh, you know the structure of reactions. Yeah, the reaction structure of electrochemical electrodes, and we may find the potential cell of each components of the reaction. However, and then yeah, we may determine whether some components can be dissolved in a solutions like hydrogen solutions. Yeah, we may see that later.
Oh, I see. Okay, please. Are you going to present your
Oh,
material
all right.
or
Yeah.
what?
Yeah. I mean, I um, yeah. I mean, I will do it.
Alright,
Can you
please.
elaborate?
Oh yeah, can
Can
you
you
wait? Why?
elaborate
Why?
the
What?
premise?
All
Why
right.
Randia suddenly laughing, man?
Because I try to understand what Andra said the last two three sentences, but I got brain fart, I guess. So it's just like I don't understand what he's speaking another language,
Oh,
so
that's right.
can you
Like
can you
hydrogen
repeat what you're
stuff.
saying?
Yeah.
Yeah, can you repeat what you're saying, Andra, previously? Sorry.
Oh, okay. Okay. Yeah. For like cell two, uh, we are discussing about how we can arrange the reactions from two basic reactions, and we may determine the potential cell of each component, and the notations of it, right? As well as we may know whether some components can be dissolved in a solution or not. Can you hear me?
Yeah, of course I can.
All right. So let's jump to
Okay.
the for Excel two. All right. We are now having exercise one. All right. So you see,
Wait. I cannot.
can you see?
It is still the PowerPoint, but it is in the first slide in my case. How about you, Randia? Can you?
Same as Adil. It's
All right.
only
So
the
let me
first
reset first.
Oh yeah, it is. Wait, why are
change it.
you?
All right. So let me reset and then I restart actually. Uh, can you see that?
See what?
Not yet.
Oh
Does
yeah.
the slide change?
Oh
Okay.
yeah. Okay, so it is.
All
Oh
right.
yeah. Now I can see it well.
All right. Right now we have exercise ones. All right. So if you already learned about the you know uh kid thought and then not you may see it. Right. The okay. So right now we have some questions and it talks about voltaic cell. Right. So a cell of voltaic that consists of electron
Consists, no
P.
consists. Oh yeah, right.
Yeah, because it's singular, so it should be added
Oh
as
yeah,
electron P or point blank, not point blank name. It is plumum.
yeah.
Okay.
Okay, that's inside joke for Indonesian millennium kid.
Yeah, and then chrome or we can say Cr. All right, so there are two electrodes called Pb and Cr. All right, so the data is like this. The electrode Pb is described as like that. Pb2 plus as aqueous plus two electrons. It could be solid, and yeah, it results the potential cell equals minus 0.14 volts. Second, about Cr3 plus, which has aqueous fast or liquid plus 3 electrons, resulting Cr in solid, and it has the equivalence uh, cell potential about minus 0.74. All right, so these are the question, guys. These are the questions. Okay, you need to determine a not encoded cathode from these two reactions. Afterwards, we need to outline the reactions in both cathode and anode. And the third, we need to outline the cell potential value, right? For
Hmm.
so if it is the uh, cell potential of each reaction of each components, then what we need to do in the third question, the uh, the cell potential for the some reactions. And the fourth is we need to outline the cell notation. It's easy. All right. Uh, so there is a rule that when it comes to voltage, okay, the bigger it is, so the bigger the voltage, it is closer to cathode, man. All right.
All right.
So do you remember that uh,
Oh, what?
why I cannot use my own pen tablet? Wait.
All right.
Wait a second, man. There is a technical issue.
Yeah, when you were talking, Andra, there was ASMR of keyboard typing.
Oh, it's not you. It's not Andra. It's actually me.
Yeah.
What?
Like this, right?
Yeah.
He's actually sorry.
Can you hear the
Is
sound,
that
Andra?
sorry about that. It's
All right,
actually
yeah,
me.
I already heard some keyboards typing.
Sorry about that.
Yeah.
I
No.
will.
Yeah, I
Yeah.
mean, I will review about Karet, man.
Karet?
Karet.
Oh, cathode
So
reduksi. Okay.
cathode is reduksi, anode is oxidasi, or we may say karet to conclude all of this.
Oh yeah, yeah, yeah.
All right,
Karet.
so all right, first, which one, which voltage is bigger from PB and CR?
Um, PB, I guess.
PB, all right, yeah, that's right. It's bigger, all right. The PB voltage actually bigger than what CR has. All right, so uh, since the voltage is bigger in PB, so yeah, cathode is PB, man, and PB is reductions. Then
All right. PB is reduction because it is a cathode.
yeah, cathode and reductions actually the decrease, right? The decrease
Yeah,
from the high
reduction
to
is
low
about the
of oxidation
decrease of
number.
electron, or is it the
Oxidation
oxygen?
number, yes, the
Oh,
oxidation number.
oh yeah, the oxygen who got reduction. Yeah.
All right. So answer A is answered. You got to answer B. What is as answer B about? Outline reactions. Okay, outline reactions. All right. So this is our raw reactions. All right. Okay. So since the cathode is let's say PB, right?
Yeah, PB.
Yeah, and then should you change the reaction then, or just let it be? Yeah, and the
I
answer
guess.
is yeah, we need to make it unchanged
Yeah, we
since
need to flip
it's
it.
already reduced.
Oh, that's right. That's right.
Yeah, it's already reduced.
So yeah, also we flip it. We will subtract the cathode with a node, right? At the end of the day. So I think the answer should be 0.84. No, 88, isn't it?
Uh,
Or not? Oh, I think I'm wrong. Oh yeah, yeah, I'm wrong. Never mind me.
all right. We need to actually first change the arrangement, okay, of the CR, because CR is actually the anode. Okay,
Yeah,
so
yeah,
it
yeah.
needs to be oxidized.
We have
All right.
to. I think we have to. How about it? Equalize the electron first, right? In order to do a calculation.
Oh yeah, yeah. We need to equalize the electrons when we are about to uh summit. Yeah.
Yeah, yeah, yeah. That's right.
All right. So it's already reducted, right? It's oxidized.
Yeah. So
So
I guess.
when we start to rearrange it, and then we need to change uh, the the minus to plus, and what you are arguing is actually like this, right?
Oh,
Yeah, we may calculate it later. However, um, first we need to find the cell a voltage cell value in these reactions. All right, so the the formula is like this.
oh,
So actually, the total E cell is the subtract of the reductions and oxidations.
oxidation.
Yeah, you are right.
Wait, hold on. It isn't really look like what I think about. Wait. So the answer is uh positive 0.6 volts.
Yeah, you are right.
Wait, what? What? Well, I'm wrong about my initial answer.
Yeah,
So,
actually, it's not the right answer, but so it is because uh, see the reduction happens in PB, right?
oh,
PB, and it's cathode, so you need to put the 14, the minus 0.14 here, and then since it's subtract, so you need to put strip here and just put the next CR potential cell, which equals 0.74 in minus.
I see. I get it.
Or you there is an alternative way to do so. You may just flip back the reactions here from the CR3 plus
Oh yeah,
uh,
yeah, and then you
resulting
literally
CR.
sum it.
Yeah, just make it flip back when you wanna add the real oxidations reactions.
Well,
And
I'm still confused here. I mean,
yeah,
I thought that the PB should be um. Wait, hold on.
what do you think about the PB, man? Should the PB
I mean,
be
I mean,
oxidized?
yeah. I mean, I thought that the electrons in both
Yes.
in both reactions should be equalized first. So I mean the PB times 2, and then out the a fault, what is Voltaic what this e derajat e, what is it
Oh,
called?
it is the potential
Oh
potential
yeah,
value.
but the potential value will also be multiplied by 3 in PB case, because the electron will be multiplied by 3, right? In order to equalize with the CR.
Wait, I mean, I wanna verify again.
The energy potential, huh?
So
Right.
I guess also the reaction are multiplied
Or
in
not?
order to equalize the electron. The
All right, so
potential value didn't doesn't get multiplied in, in this reaction. Is that right?
yeah, I mean, I think that here the uh the solution, right? I mean,
I don't think it's multiplied,
Yeah, that's right.
because it's energy potential. So imagine you have this difference in height, right, Adil?
Uh,
And no matter how much the imagine a waterfall, all right, you can have a wide waterfall and a small waterfall, but no matter how wide it is, you don't the height will not change.
oh, I see.
Something like that. That's the best analog that I can
The head
provide.
doesn't.
Does not change.
Yeah,
So
yeah, yeah,
yeah,
yeah. That's
there could be
why they
yeah.
didn't. The
Mm,
calculation doesn't
oh,
make the potential got multiplied.
that's true because
Uh,
you said the water could be far many, right? The water going through the waterfall, but the height will still doesn't change at all.
oh yeah, 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 yeah. That's
Something
right.
like that.
That's right. Yeah.
yeah, I mean, I think that's yeah, we don't need to multiply the voltage as we multiply the reactions. Uh, here's the formula, man. I mean, like uh, this is the rigid formula. I mean, even though you don't understand about the reactions, just put it the voltage here, E reduction and E oxidasi, and you may find the right answer afterwards without having busy to arrange the
Yeah. So
reactions.
we literally just um
But
subtract stuff.
subtract, yeah. But I mean, from what I'm experiencing, when you do the reverse, okay, the reverse, like for example, from CR 3 plus 3E resulting CR, and you have E cell equals minus 0.74 volt to be like this. CR resulting CR3 plus 3E having the potential value equals plus 0.74. So the volts changes to be plus from minus.
Mm,
Yeah, that's what I know. I mean, yeah, but I think that there's no correlations of multiplying to be multiply the volt too.
I see. I get it. I get it.
Right. And then okay, so next we are about to make the arrangements of cell notations. All right, so cell notations will be right like this. Simply there, there has the strip and double strip and the strip again. It means that the the first side left of the double strips means not sides, and the right side of the double strips meaning cathode. Yeah, it is because when it comes to a knot, it becomes oxidations, and the oxidation happens in the CR reactions. As you can see here, the Cr oxidized from 0 to +3. And yeah, the reverse is Pb. Pb experience the reductions, so that we write like this. All right, so the next is about the Ne2 plus 2E equals or resulting Ne, and the Al3 plus 3E equals Al. And we have the voltage guys here. All right, so the questions are likely similar to the previous ones. So my question is, which one has bigger voltage in these examples? Hello, Tess.
What? Yeah.
All right, so
Yeah, I can hear you.
Adil, Rendia, what do you think that which one is having a higher voltage between Ne and Al?
Of course,
Or
it is Ne, and it is nickel, right?
are you sure about it? Are you
Yeah.
sure, Adil? Oh yeah, yeah, that's true.
Yeah.
Some play. Yeah, okay.
You
All right,
see,
so uh, Ne voltage is bigger than Al voltage.
Al is aluminium, right?
Yeah,
Yeah.
this is nickel and nickel. Nickel is the source of battery in Indonesia.
Yeah, but it is a failed project because nobody want to invest. Is it? Oh no, Tesla just didn't want to invest in Indonesia.
Oh, really?
Wait, is it?
All right. Well, I don't really know about it. However,
Okay.
okay, let's jump to this. Cathode is the reductions.
Oh,
And
cathode is
what would be
reduction.
reduced in here?
Of course, it is the oxidation um bilangan. What is bilangan?
Oxidation number.
Oxidation number.
What would be the cathode here between Ne and Al?
Ne. Oh, Ne, right?
Really?
Ne. Yeah, because
Ne?
the cathode is the one who has. Wait, hold on.
Yeah, yeah, that's true.
Oh yeah.
Yeah, and Al, because uh, when it comes to cathodes, the voltage should be bigger than the partner
Yeah,
or
yeah,
the
yeah. The voltage
counterpart.
should be bigger.
Counterpart.
All right.
Remember, cathode, karet, cathode reduksi. All right. So here's the thing. All right. When it comes to the reductions, all right. So does Ne is already reduced or not?
And reduction. No, no.
Really? It's not reduced yet. It's not reduced yet. Do you think like that?
Reducted means the oxidation number is
It's decreased.
decreased.
Yes,
So
decreased.
because the oxidation number is decreased, it means
Yes.
that the electron increase instead.
Yeah, yeah, you are true. Very true.
So guess the cathode reaction will be Ne and the anode reaction should be aluminum.
The anode reaction should be what?
Aluminum.
Okay. Yeah, you are true. And uh, the reaction is like this actually. Ne2 plus. So the Ne reaction stays same
Stay
since
same.
uh, because actually the oxidation number is still same.
The
Uh,
oxidation number is still same.
yeah, as you can see that when the Ne actually has ion here 2 plus, right? Okay,
Mm.
so just write +2 and here 0. So the relation between Ne here and Ne the counterpart side is decreased. So from +2 to 0, it means there is a
It
decreasing
yeah, it is decreasing electron.
decreasing electron. Exactly.
Yeah.
All right.
Um. All right. What?
Okay, and then what about anode?
Well, it is the other reaction, which is the aluminum,
Like what for first?
like Al 3 plus and 3 plus and AQ aquatic from
Oh,
eh
well, actually, it should be uh, initiated by Al solids
Al is
because
solid.
the reaction is actually reverse since it's oxidized from zero zero oxidation number to plus three oxidation number.
Oh, I see.
Yeah, like this.
All right.
All right, and then however, as far as I know, the cell voltage is actually changed from minus to be plus. Okay, so yeah, we have the cathode reaction and anode reactions. All right, so about the E cell or the uh, potential cell of the reactions would be what minus from what subtract what.
From Ne subtracted by the aluminum, so it should be 141. Yeah, it is 0.25 subtracted by negative 1.66. The
All right,
result should be positive 1 point 41.
0.41.
Yeah.
All right, all right. Let me check the key answer to make sure.
Yeah. Well, Andra,
Okay,
do
yeah,
you
that's true.
mind? What? What? Oh yeah.
Yeah, yeah, it's really true. I mean, it's uh from the subtract of the reductions potential cell to oxidation potential cells, and it results in plus 1.41 volt.
1.41 volts. I see.
Yeah, and then you may do that like this too. Like first, just write the uh, cathode reactions so that you may write the anode reactions afterwards. This is the second alternative way to find the E cell.
Oh, I see.
Okay, yeah. And then you see that the E cell of Al actually is already reversed.
Yeah,
And
it's
then
already reversed
you may yeah, just calculate
by
just
summing all of them.
by summing all of them, and you may see that the E cell is like this. All right. All right. So what about the uh, notations?
What?
What about the notation of the reactions?
Oh, it will be Fa. Wait. Ne.
All right.
At
First,
the
okay,
left, one at the most
when you
left.
are when you are sure that the uh, not NE, right?
Yeah. Oh, oh yeah. That's. Oh yeah. I think I see it wrong. It should be Al, and then A aluminium, and then aluminium plus three, and then Ne plus
Plus what?
one, and then
Plus
Ne.
one.
Yes. Yeah. Yeah. Plus one.
All right, let me check. All right, actually, Adil, Al is actually Al 3 plus and Ne 2 plus.
Oh yeah. Yeah. That's.
All right, I also reverse in terms of writing the ion here.
Oh yeah. Yeah. That's right.
Eh, like what? Oh, okay, okay. Is this what you mean, Adil?
Yeah. That's right. And wait. Oh, yeah. Yeah. That's right. So I mean.
Okay, and we should put E cell here, right sides of the notations.
Right side of the notation. I see.
Yeah, and we have 1.41 volt. Well, actually, it's common for battery. Like battery, actually, a common battery has 1.5 volt for its voltage. Okay, this is the exercise 3, man, and yeah, I mean the question is a little bit unique compared to the prior questions that we already had. And now we need to determine its components in terms of their respectively voltage number or voltage value, potential voltage value. And what we are given is just from the notations and just one reactions that results in the minus 0.40 minus 0.13 volt for the PB components, right? So yeah, we need to calculate. I mean, outline the reaction first. After that, we need to calculate it. All right. So okay, you see that from the first reactions, yeah, from the first reactions, we have this 2Ag Ag2 plus CD resulting into Ag plus CD2 plus.
Wait,
And
Auli, are you sleeping?
What?
Adil, are you sleeping? Are
Wait.
you
Wait.
sleeping?
Do I
oh,
sleep? I don't know.
Oh my god, this become a lecture. God,
all
Wait.
right, yeah.
Wait. Do I sleeping?
did you sleep?
I don't know, man. Wait.
I mean,
Do
I
I?
saw that your eye closed and your head just
No. No. No.
laid
Please
down.
continue. I don't know why I
Oh,
become
maybe,
like this.
maybe Aulia
Holy God.
Adil is still prioritizing their ears, I
Oh,
mean, instead of eyes.
I see, I
What
see.
instead of ice?
No, no, no. So, do you hear what Andres said for the last couple seconds there?
Yeah.
Like,
There's reaction stuff, right?
he wants to, yeah, yeah. But
Oh,
Need
all right.
to combine.
so we have this for cathode anode reaction in cell notation, and then uh, you want to determine which one who has electrode potential, the highest electrode potential. Is that true, Andrea? Something like that?
Yeah, actually, we are trying to outline the reaction from the
Yeah,
notation first. After that, we need to calculate from the cathode and anode to find the exact numbers of each voltage.
yeah. Okay, go back now. Let's just screen
Yeah,
again.
So
I
by
mean,
the way, guys,
yeah,
Ashar is
if
really
Oh
quick, right?
yeah,
It's
yeah, yeah, yeah. Ashar
fourteen
is
forty
really close.
nine. So we have 8 minutes to go.
Hmm.
So let's continue, Andre.
Continue,
Just
continue.
want to
Just weekend.
remind you.
all right. as you can see, guys, that the notation is like this.
Got it. Mm.
The notation is like this, and the reaction is like this. The
Okay.
notation of this second is like this,
Oh
and
yeah,
the
yeah.
notation from PB. Okay, as you can see, PB. What is the left side? Is it anode or cathode?
It is a note.
Yeah, that's right. And then
Okay.
the
Mm.
and
And
the
the last.
lastly we have Na and PB, and the reaction between Na and PB is like this. Okay,
Mm.
with
Good.
the same remaining voltage, still the
All right.
same.
Is that all?
All right.
Okay. The calculations there.
And the calculations is simply, man. It is in the basis of the uh,
Yeah, it's like a linear equation. You basically to find each of the each element
yeah,
electropotential.
unknown
You
element. Yes.
yeah, you need to determine which is system equation basically. I got it.
Yeah. And then
Mm.
yeah, you are right, Randy. Yeah. We put the E cell here, okay, and the
Mm.
unknown between E cathode and E reductions depending on the reaction. For example, right, means for the Ag, means when you are wanting to find Ag or argentum here,
Yeah.
okay. So since the Ag has a role as the cathode or oxidizer, yeah.
Mm.
So the numbers of oxidations is reduced. Okay, so we need to put here as the cathode, and then the nouns data from the PB here.
Okay. Yeah.
All right,
You already have.
PB
So
is reductions.
got it. Got it. Mm.
Wait, what?
Wait,
Why?
wait, wait.
Why do? Hold on.
All right. Okay, okay, okay. Oh, I mean, I'm wrong. I'm wrong. It's not that reactions. Yeah,
Mm-hmm.
I just wanna attest you if you are sleepy or not.
Got it. Uh, right. What?
I mean, the reaction is not true, man. I mean, what actually true is here, the reactions.
No, yeah, I mean, so you have this whole reaction, not half reaction, just a whole
Oh,
reaction within this
this,
cell, right?
it,
And it
and it's not
results,
reduction, man. It's a not.
huh? Yeah, it's a node, yes. But
Yeah,
listen, you have this electrode potential, all of them, and the last equation is the half reaction of the PB, right? Basically, the energy potential of the PB. Basically, with this system equation, you calculate for each element in the so in this case, you need to search element Ag or silver with using the two equation of Pb and the cathode anode reaction basically.
Yeah, yeah,
So
yeah.
yeah,
That's
something
right.
like
I
that.
think I get it.
Yeah, yeah.
yeah, you are
It,
true. And yeah, we involve the half reaction of PB in order to find the each components is
mm,
cell. Okay,
true.
as well as we since we are given the total reactions potential. So yeah, it makes easier to put that reaction cell here.
Okay.
All right, and then for example, like this, in when we are searching about the AE, and I use these reactions. Okay, and then
Mm,
all right, so here is the reaction, man. Means the total uh the reaction cell would be 0.93, right? So since Ag is cathode, so we need to put it here, and then since the PB is anode, if I'm not mistaken, anode, right? And
mm-hmm.
yeah, it could be located here. And when we do algebra, when we do algebra, and then we find the cell of Ag equals plus 0.8 volts, and yeah, it happens for all components below.
Okay.
Oh yeah, 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 yeah. I think
All
I
right,
get
so
it.
the answer B, what is the answer B? Put in order based on reduction ability of each of metals from the weakest to strongest. Okay, so the point of the number B. All right, so we need to arrange of the order of the metals. Okay, from the weakest reduction ability to the stronger reduction ability. Okay, and it is the results. Okay, so uh the more it is below, all right, so the stronger it is.
Got it.
All
Okay,
right.
so what do you think it's true?
What
What
true?
what do you think it true?
Yeah, what do you think this order is true?
Is it true or not?
Yeah, of course it is true. You know.
I guess it is true because yeah, AG
Yeah,
is
it
the
is.
biggest and the
And
NI
I
is
is the weakest, the
the
lowest.
weakest, I guess.
Yeah, yeah, you are true because the AG, as you can see, has the strongest or the biggest voltage
Energy
number,
potential
yeah,
voltage number here.
the potential number, and then the weakest should be Na or sodium because sodium has the weakest number of voltage.
Mm-hmm.
All right,
Got
so
it.
it yeah minus 2.71 volt is the lowest number of potential value.
I see.
Continue. The source C metal solution.
All right, so the number C, if those metals, okay, if those metals are put inside Aulia and Rendia inside the acid solutions or H plus hydrogen plus, which metal that are able to be dissolved or reacted and which are not? Okay, these are the questions. All right, so we need to determine whether these metals are dissolved or not. If they are put inside the hydrogen solutions or acid.
I think it's the opposite. Like if they are in the negative voltage, I think it will be dissolved. I guess maybe I don't
Oh,
know.
you're not
Is it
true.
true?
You're not
I
true. You change.
I'm false. Okay, I'm not. That's not correct.
Then
Uh,
please read this.
The
In order
solution.
for a
Oh,
metal to
should
be
be
dissolved in H solutions, the E reaction should be above
oh zero
uh,
volt. I
zero
guess.
volt.
Okay.
Zero
Since
volt.
the two H plus is defined at the 0 volt.
Okay. Okay. The negative testing. Hello.
Yeah, can hear Randy. Yeah.
Yeah, Andra is lagging.
Yeah, I mean,
Let's see.
yeah, I give you a time for understanding actually, and then yeah, we see
Let's see.
when Na should be faced in front of H plus, and yeah, the what would what would be reduction man or cathode?
Oh, the cathode will be Na, the not the sodium.
You're not true again. The
The
cathode
cathode
actually
Oh
will be the
yeah, that's right.
hydrogen because
Hydrogen.
it has a bigger
Yeah,
number.
and I right now already flip. Yeah, yeah,
yeah, it's already flipped.
yeah.
It's already flipped. You are very true. And because the number here is bigger than 0 volts, then it's dissolved.
Yeah, yeah, that's right.
And it happens for all. So my question is Na dissolve, okay, dissolve in the hydrogen solutions. What about CD?
Dissolve two, PB dissolve two, but the rest is not dissolved.
Like this?
Yeah,
All right.
I mean zero is pretty much
Wait, what?
just.
Why? Oh,
I
because
mean
it
the
is below
reaction.
zero.
Yeah, because it's below zero. I mean if you have zero, it's easy to determine. It's just determine between positive side